Hello, this is how to use the KDE Kate text editor for C programming. So Kate is the KDE's advanced text editor, does support LSP language server protocol, has syntax highlighting, has Git integration, has DAP debugger adapter protocol support, etc. And this makes it possible to use a variety of programming languages straight in KDE Kate. This is what we have, a sample C programming language project, the simplest possible. It just writes hello world and it uses the simplest possible cmake list.txt file. Let's start Kate in the current directory and make it open the current directory, which is the directory test C. This is how it looks like. It uses the tool window projects to show the structure of the current project. It can display all of the files, uses the correct syntax highlighting for each file. We can see it in the status bar where it says the C programming language and the CMake programming language and Markdown. Next up, we want to look at the output where it says that there's an LSP language server protocol client warning. It wants to find the executable clang-d in your path. So in one of the directories in the path environment variable. It also wants to find the executable marksman for LSP support, language server protocol support for Markdown. So let's satisfy these two warnings by installing the executables clang-d and marksman. Let's open a terminal, become super user, and hunt down for these two executables. I'm on the Linux operating system Kubuntu 25.10. Let's install apt file, update, apt install apt file, apt file update. Make sure that apt file knows about the list of available packages in the package repositories. And now we can use the executable apt-file to search for which deb package in the remote repositories contains the file clang-d. Apt file search clang-d. Let's use a slash at the start. Okay, so there's a variety of clang-ds for the deb packages clang-d -19, -18, -17, -14, etc. And there's a deb binary package clang-d. So probably this is something similar to alternatives and is going to use the correct clang-d version depending on the actual clang version that you have installed on your computer. So we want clang-d. Okay, after this finishes, we will want marksman. So apt file search marksman with a slash. So both apt file search and apt search say that there's no deb package that's providing /usl/bin/marksman. And apt search marksman says that there's no package, the package with the name marksman. So probably marksman is not yet packaged for the Debian Linux family of operating systems. This is probably the GitHub repository. Artempiani KH marksman. Straight in the readme file, it says that you can install it using snap. So let's do that. Snap install marksman. This is one of the more complicated executables, probably because it uses the F# programming language. It's probably the first project that I know of that uses F# on Linux. So it says that the snap package has finished installing correctly. Let's reopen Kate in the same way that we did previously. So we tell it to open the entire directory test C. Says that there's no git version control for the current directory, which is correct. Do you want the LSP server to be started? Full command line /usr/bin/clangd, and then a number of command line parameters. So it says that there's a Kate plugin that asks these things, and that KDE plugin has a configuration page. Okay, so in output we see LSP client, that the LSP client for the C programming language has been started. Let's see if the same works for files which are written in Markdown. Do you want the LSP server to be started /snap/bin/marksman space server? Yes. Let's look a bit at the Markdown support in Kate. There's auto completion. Let's see if there's Markdown preview. So that would be from the special plugin for document preview. This one. Now we have this button for previewing, and it says that I do not have the K part for Markdown previewing installed, so let's install that. apt search Markdown part says that I do not have yet the package Markdown part installed, so let's install it. Let's restart KDE Kate. readme.main, readme.md, and it doesn't really support pre. So let's remove all of this support. Settings, configure Kate, plugins, and document preview. Let's look at the support for the C programming language. So we have syntax highlighting, we have the minimap, rich documentation, tooltips on hover, says including the list of symbols that are imported from an include.h file, the full path of the .h file. There's symbol list for the currently open file, file system navigation, go to symbol, control click. And including it says that this is a string literal, which is correct, and that it is 14 bytes. Inside the main menu of Kate, we have an entire menu item dedicated to LSP clients. Let's see them one by one. LSP client, go to definition. Correct. LSP client, go to declaration. I don't have the CPP source code of printf. Go to type definition. This is a macro. I'm not sure what it did here. So it went to the type struct file. Okay. Find references. There's a tool window, LSP references standard output. Find implementations. No results. Switch source header. So if you have a pair of files with the same name, different extensions .c and .h, it will switch between those. Symbol info. So you can see that the rich documentation tooltip, when you hover on top of a symbol, actually comes from the LSP client. Highlighting. Search and go to symbol. Cool, cool. Okay, let's mess up the formatting. And it has selected an interesting formatting style, but we can live with this. Rename. So this is one of the simpler refactoring supports where you rename, for instance, a local variable. Let's see if it actually works. Okay, so there I thought that I messed up the syntax. We have a warning, says insufficient arguments for formatting. We need more arguments. Auto-completion has selected the correct value. Okay, let's try to rename the value. LSP, rename F2. And it does replace in two places correctly. The selection is interesting. So this yellow highlighting with the background of the text only highlights 5 characters, not the entirety of the length of the minimum identifier. So there's a bit of clash between whatever the LSP wants and whatever the Kate text editor wants. Like LSP wants to use 2 spaces indentation, but then the text editor wants to use 4 spaces indentation. Let's see if I press enter at the end of line 7, and there it does correctly. It considers the indentation of the previous line. Okay, next up, LSP client expand selection. It has selected the string literal. It has selected the entire instruction, but not the semicolon. It has selected the entire body of main, including the curly brackets. The entirety of main, including its signature. And back to nothing, no selection. Okay, the opposite shrink selection. We can close all dynamic reference tabs, probably closes these tool windows of LSP, highlight references and references. Let's see. And it does. We can restart the LSP server. It's probably if you close all of the Kate instances, hopefully the LSP servers will close. Presented as a JSON, the usage of the LSP server, memory usage. Oh. A feature that people might want is the LSP client more options format on typing. Let's see how that works. Format on typing. I don't see how that works. So the LSP format Control TF does work, but then format on typing, I'm not sure how that should work. Next up, we want to build the project using this cmakelist.txt file. Let's look a bit at the Kate product manual. So from the Kate main menu, help, Kate handbook. Let's search for build. So it says that there is a Kate plugin for building. Let's install it. Plugins, build and run. There's code completion for CMake files. And there's also the debugger. Okay, so says that there's new tool windows, target settings and output. There's a file, hidden file .kateproject.build. And there should be a top level menu item build. So let's see what it does by default. Build and run selected target. Nothing configured yet. Build a selected target. The documentation says that inside the build menu, there's a load targets from cmake cache.txt option. So build, let's do that. Load targets from cmake build dir. So in the parent directory, there's the cmake build directory, and in there, there's cmake cache.txt. Kate build plugin needs to execute an external command to read the targets from the build tree. Proceed. So let's see what it imported. This is what we have executed previously. So we did cmake configure, the source directory being this one, test C. The build directory is the parent directory test C underscore build. So it's an out of directory out of tree build. So rerun cmake minus B the correct directory and minus S the correct directory. So this part is okay. For building, we go cmake minus build. And minus parallel, this part. And then we run the executable. So it looks okay. Let's do this, including it has created a clean target. So let's see one by one. Rerun cmake. So you need to select a target, and then the button is this one, build selected target, or from the main menu, build selected target. So let's do clean first. Let's see what that actually did. So it created a .kate project.build hidden file. Okay. There's a compile underscore commands.json file. That also looks okay. And in the directory test c underscore build, there's no executable test C. Okay. The next one. So build, select target, rerun cmake, and build selected target. Generating done. The output is too short. I'm not sure where I can see the full output from cmake configure step. Maybe it's an incremental cmake configure. Okay. Next up, test C, build, compile current file. What is that? Build selected target. Let's make sure that the file has appeared. Yes, it did. Test C underscore build. If the executable file has appeared, test C. Okay, how do we run? Build and run selected target. Where do we see the output? From the application. Okay, so at least we know how to run clean, rerun cmake configure, and how to build the target executable, which is named testc. Next up, let's look at this tool window, which is symbol outline, which does use LSP for the CMake list.txt top level file, it says that there is no language server protocol available. Let's look at more complicated C programming language files that have more symbols. Okay, so what you would expect, the structure of the file showing symbols that are defined, so types, functions, etc. with symbol name and a icon. These are the symbols, so global static variables using this icon, and this icon is for functions, for free functions. Okay, and if you switch the line, it also switches the symbol that's currently selected in the symbol outline tool window. You can sort alphabetically. You can show details, the entire signature. Again, you see the outline of the current file also in the current tab where the file is open. There's a combo box like this. And the combo box respects the settings that you configure here in the symbol outline tool window in the hamburger menu to show, for instance, details. And everything works correctly. Okay, so let's read a bit the documentation for the build plugin. It says that there's a tool window build at the bottom. There's the tabs, target settings. And in there you have two possibilities for storing the setting. There's session and project. So project means that there's a hidden file stop level in your project named .kateproject.build where the setting is stored. And session means that whatever you edit in here will be stored in the current Kate session configuration. So we did well to use projects. We did well to import from the cmake cache.txt file. But now we also want to populate this column run command. So for test C, it uses the working directory, the correct one, test C underscore build. And let's add a command to run. I'm not sure what this thing does. So it has opened a file open dialog in some random place. If this is the correct current directory, test C underscore build, can we just specify test C? Okay, so let's try to build and run. Okay, doesn't like that. And that works. Okay, so again, the working directory. The second column of the first row in a target set, so this column, target set, this guy, directory, is used to configure the working directory used for compiling and running commands. If the project plugin is enabled, which it is by default, this guy, the working directory string can also contain placeholders for the project-based directory. Percent uppercase B and percent lowercase b. So project-based directory. So you can go use relative paths instead of the full paths towards test c_build. Okay. Then there's a build command, which is the second column in the non-first row. So probably the first rows are session, projects, and this one. And then the non-first rows will be all clean, rerun cmake and test c. So the second column in the non-first rows will specify the build command, which is correct. cmake ---- build, correct directory, and parallel, which is what we wanted. So this one. We can use placeholders, %f for current file, %d for the directory of the current file, %n for the base name of the current file. Yeah, fortunately, all of these paths, and especially full paths, have been computed correctly by the Kate build main menu load targets from cmake build dir. Okay, and then the last column, the run command column, the third column of the non-first rows, can contain a shell command. So you can probably also have command line parameters. There's an actual terminal that's being started in the selected target build, the selected working directory, which is test c_build. Terminal is opened as a tab. Okay. So I am satisfied with what I see here. We have clean. We have rerun cmake. And we have the possibility of just building test C, the final executable, the cmake target, or build if needed, so incremental build, and then run. Okay, and this is also really easy to document in a procedure and to reproduce. You just enable the plugin, the build plugin, and then you go from the Kate main menu, build, load targets from cmake build directory. Make sure that you have used your documentation to build your project using cmake first, such that a cmake cache.txt file exists. The only thing that you need to remember to do is to edit the run command. Next up, and probably the last thing that we actually want, is to see how far the debugger works in KDE Kate. So for that exists a Kate plugin. Let's go back to the product manual, Kate handbook, something with debug, GDB plugin. The contents of the handbook might not be as up to date as the Kate application itself. Okay, so what are we using to compile the software? I don't know. Whether GCC or CLang. So from the test c_build directory, there's a compile commands.json file, which says /usr/bin/cc. Let's see who is this thing. Which cc minus version. Yeah, it's probably GCC, but it doesn't say anything about optimizations. It also doesn't say anything about debug symbols. Because the CMake configuration doesn't say anything about the configurations that we actually know from CMake. So rel with debinfo, debug, etc. And it actually says config none. So a good moment would be to actually make sure that the CMake build configurations rel with debinfo and debug are defined in your CMake list.txt file. So I managed to do just that. I got to a place where compile_commands.json says that it's going to create a debug symbol. So gcc command line parameter -g. Let's see how I did that. So first of all, I have deleted the out of tree build directory test c_build. Then I have edited my readme.md file. What I have added is the CMake configure command line parameter -d CMake_build_type equals debug. I'm using the built-in terminal in KDE Kate that has the shortcut F4 on my keyboard. I'm running CMake configure. I'm building. I'm also running the build executable to make sure everything is correct. Then I go to the build menu, select target, and I make sure that I have cleaned up everything in here. So there's this button for deleting the current target. Oh, that's a strange thing. Let me restart Kate and also delete the configuration file. So .kate project.build. Okay, and now the tool window build target settings looks okay. From the main menu, of Kate build load targets from CMake build directory. The source code directory testc up1 directory testc underscore build cmake cache.txt open, and now in the command line parameter ---- config it says debug, which is what we wanted. At this point we can just remember to add the run command, which we always need to do manually after we go from the Kate main menu build and then load targets from CMake build directory. And then we can just build or build and run. And now we can look at the compile commands.json file, which exists in the testc underscore build directory. But there's also a symlink in the source directory. So gcc -g main.c and the output file. Okay, so now we have the prerequisite that if you want to run a debugger on the executable testc, you definitely want the debug symbols available, not stripped, and no C programming language optimizations for the C compiler. Now let's make sure we have GDB working correctly. Okay, let's go to the testc underscore build directory. Let's open a console in here. Let's make sure we have GDB. Let's run the executable testc under GDB. Debug info d no, never, and it finished correctly. Let's run it again, see if GDB sees the source code. So GDB does see the source code. Knows how to break Okay, so everything works correctly. The executable testc has been compiled correctly for GDB to do everything that it can on it. Okay, so let's try to enable this plugin from the Kate main menu, settings, and configure Kate, and plugins, and it should be named debugger. Yeah, the plugin is not named debugger, but Kate debugger. Okay, it used to be named GDB plugin. Okay, so we have additional buttons added to the Kate main toolbar and a top level Kate main menu item, which is named debug. Command dart debug adapter. Connection with server closed, DAP backend. Okay, let's try to configure this plugin. There's a tool window named debug. There's the debug output that says something about Dart, but we're not using the Dart programming language, we're using C. There's a settings tab. There's a combo box here. Let's select GDB. How do we create targets? Can we rename this one? What's the name of it? Test C. Executable and working directory. Executable name, should it be short or long? And arguments, keep focus, redirect IO. Sounds okay. Just to be extra safe, I have put the full path to the build executable. Let's create a breakpoint, line 4, toggle breakpoint break from the Kate main menu. Toggle breakpoint break, shift F11. And let's see if the debugger starts correctly. Start debugging. Let's see the output. Says it's using GDB, command line parameters -i-dap. It selects the correct build directory, test_build, correct executable to start, runs in terminal, breakpoint 1, main.c line 4, correct. Started, loaded SO files, and it's stopped at the correct line, which is line 4. So everything was intuitive until this moment. If I hover on top of a symbol, it still shows the documentation tooltips, not the debugger tooltips. Let's see a bit the documentation for the plugin. Says view tool view show debug view. Show debug this one. Show locals and stack. View tool views. Show locals and stack. Where is the value? Okay. Next up, debug targets. A submenu containing a list of targets. The one that we have configured in settings. Debug start debugging we already executed. Kill stop debugging. Let's see what it did. So it exited and closed the GDB. Okay, the same thing, started GDB, braked on line 4. We can see the local symbols, CPU registers, the call stack, just one thread, just one function, restart debugging. Toggle breakpoint we have used, clear all breakpoints. There should probably be a view, a tool window with current breakpoints. I'm not sure where that is. Step in, step over, step out. Let's see these buttons. Step over. Now the local variable is initialized. Previous variable has value 0. Minimum local variable is not initialized yet. Step over. Step in printf. Cannot open file. There's no source code file for the body, for the lines in the body of the implementation of the function printf. Step over, it's still inside printf. So we need to go step out probably. And now we can go step over. Step in. When we go step in, we don't have the source code of the body of the fflush implementation, but we can see that the call stack is what we would expect. So we're not inside main.c line 7, but we're inside iofflush.c line 32, a file that we don't have the source code to. And there's other local variables in that function. And we can step into functions that we don't have debug symbols of or the source code of. Okay, at some point fflush has finished. We're back inside main, and now the process is going to stop if you press step over enough times. Connection with server closed. The experience is as I would expect. The experience is correct, the experience of debugging in KDE Kate. Next up, let's see this thing print value. Let's put a breakpoint in here. Let's remove the breakpoint on line 4. Start debugging. We already have the lockers tool window, but we also have debug print value. Let's use that. So we want minimum, debug, print value, and it actually executes GDB command line commands or DAP command line commands. Print and then the name of a symbol, minimum. Settings, toolbars shown, GDB plugin. Toolbars shown, debugger, debug plugin. Okay, that removes the debugger buttons from the main toolbar of KDE Kate. We still have a ton of buttons while the debug session is running inside the debug tool window. So there's continue, stop, toggle breakpoint, step into, step over, step out, run to cursor. All of those buttons that existed in the where is it? Settings, toolbars shown, debug plugin also do exist in the debug tool window. Yeah. This is too wide and too verbose for my taste. Too much text in here. So probably I'm going to hide the toolbar debug plugin. Okay. I can always use the main menu. Let's see if the button to restart works. I couldn't tell. Let's change the breakpoint and restart. It should stop on line 4. Right now it's on line 6. And it did. It's just strange that it jumps to the tab settings, which it should not. If I'm inside the debug output tab, when I press the restart debugging button, it should remain in here. The settings I edit once per day, whereas the other tool windows I use 1,000 times a day. Okay, and for extra functionality, we can run command line commands either towards the DAP debug adapter protocol or towards GDB. So debug view, this one, the debug tool window, and then debug output. And we can run commands in here, print minimum. Let's see if run works. Nope. Nope. So these are indeed not GDB commands, but DAP commands. Opens a new IO tab in the debug view where you can view output and provide input to the running program. Let's see that setting in action. So redirect IO. Let's restart. And now we have this terminal tab. We have the output of I know. Let's step over a number of times. And now we can see the standard output from our executable test C. But we can also see the standard output from GDB. Okay, we see the call stack. We have the locals. We have threads. Yeah, it's as I would expect, works correctly and worked correctly until now. The settings were intuitive, nothing more to add. Yeah, so I'm pretty pleased with Kate. So I actually use Kate. It's actually bound to my F4 key in my file manager. I use Crusader. So F3 is view. It uses the Crusader built-in viewer. That's read-only. But F4 is for editing files, the file that's currently selected in Crusader, the file manager, and it actually opens in Kate. So it's my preferred text editor in graphical user interface mode. It's fast. It works correctly both on Linux and on Windows. It has the features that I use. I support it because it's part of the KDE community. But then it also has additional features, not just as a simple text editor that can show you the file system structure and has syntax highlighting and minimap and replace and regular expressions and everything that a text editor has, but it also has additional powers in the form of LSP language server protocol support and DAP debug adapter protocol support. And we saw all of these for the C programming language. Thank you.